Okay, so today's and maybe the next lecture would be about application layer. As I told you that I'll be starting from the top layer to the bottom layer. So, and the book we are going to follow is Computer Networking, the top-down approach from Kuros and Ross. So from now onwards, most of the material will be covered from that book. Fine. So I would suggest you to purchase that book. Uh, that is sixth edition is Indian edition. I am not sure about the seventh edition, but if you can get the seventh edition, Indian edition, you can purchase that book from Amazon. So the book is Computer Networking Top-Down Approach, and the authors are Kuros and Ross. Jim Koros and Keith Ross. So this book you should purchase. This will help you. It's one of the best book. There's one more book which I'm going to follow. Should not purchase that. I'll be giving you the handouts of that, and that is Computer Networking by Peterson and Davy. So should not purchase this, but this is also a very good book. So if you want to know deep details of computer network, these two books are important. So what in this module we are going to see? We are going to see application layer and uh, basic objectives are implementation aspects of network application protocols and what different kind of transport layer service models uh, which can be utilized by applications depending upon the quality of service any application desires. We'll be seeing different paradigm of making network application. Two popular paradigms are there. This is more traditional one, the client server paradigm, and recently from last 10-15 years, this particular paradigm is also very popular, the peer-to-peer paradigm. So we'll be seeing both of them. Some popular application level protocol we'll be seeing HTTP, FTP for your mails, SMTP, POP3, IMAP, and the most important one, the DNS. So this is what is going to be in this module. It will take 2 lectures, today's and one more lecture. Now you are using these network applications from long back, the email, the www, instant messaging, remote login using SSH or Telnet, PTP file sharing, you have used BitTorrent, and in our institute you have used DC++, multi-user network games, you are already aware. I think which one? Counter Strike is most popular. Bhavya, Counter Strike. बताओ बच्चा लोग गेम नहीं खेलता है तुम लोग
Sir, PUBG also.
PUBG is also popular. Okay. Uh, then you are also aware about this YouTube and all those streaming videos, the Prime Video, Amazon, Netflixes and all. Voice over IP. Right now we are using that only. Voice over IP. Real-time video conferencing. That is what uh, these two things were very popular, very much popular during this pandemic period. So all these network applications you are already using, and in this course will be our goal is to design network application of our own and how a network application can be designed. For that purpose, you need to know the internal details of protocol stack and how these different protocol layers work together to provide that network application uh, an environment to run and to provide that network application desired quality of service. That is what is the goal of this course. If you want to create a network application, uh, you want to write programs that run on different end systems and they communicate over network. For example, the most popular one is your browser running on your end system communicate with a web server software which is running on any web server for fetching web pages. Fine. You are not required to write software for the core devices. When I say that uh, core devices, so our internet can be roughly divided into two parts. One, the inner core, where all those routers and forwarding devices are working together to transfer your data packet from one place to one end host to another end host. And the another part is your end devices. So the whole internet is made up of the core of internet, which is having your routers, switches, forwarding devices, and then edge of internet where your end hosts are there, and these all together form internet. Network core devices do not run applications. Application on end systems allows for rapid application development and propagation, because when you have these network devices, these are having different authority of different stakeholders. When suppose somebody asks you who owns the internet is not owned by anybody, any single authority. It is like network of networks. So there are different ISPs, different organizations. They are having their own network, and then these network connect together to form a bigger network, so on and so forth. And in this way, the internet is developed. So what is the actual thing that we are not going to, when we talk about application, we are not going to touch these forwarding devices, the network in between. So we are more concerned about writing application which can run over the end host. Fine. And these end hosts can run all the protocols layers for forwarding your data. Fine. This is what is internet all about. Why we wanted to have application running on end system? Because this allows rapid development. Fine. Because changing property of any router, fine, changing the way router is working, the functioning of any router is very difficult, because you can see this router and other routers are interdependent on each other. Fine. So if you see in last 10 years, what we have visualized, or what we have actually experienced, that there is there are a lot more focus on app development, application development. There are so many applications due to proliferation of mobile networking, due to proliferation of smartphones. Fine. We have application literally for everything. So it's a rapid focus, a rapid pace of development of applications. And we don't say them application, we say them apps now because there are so many. So our focus on this chapter is how we can think about designing an application. And when you want to design a network application, you are not worried about, not very much worried about these layers, the network, data link, and physical. Fine. You are more worried about the code part of your application and how this application can actually interact with the layer below, that is the transport layer. Fine. And we'll see this thing in our lab. When we see socket programming portion of our lab, you'll be able to develop your own network application which can run on different end systems. Different application architectures, the client server, the peer-to-peer, and this is now getting more popular, the hybrid of client server and peer-to-peer. Now, client server architecture, there is a general belief that server should run on a system which is always on, which is always available, which is going to have a permanent IP address. Fine, fine. And if it's a huge server like Google or Microsoft or the server which gets more requests per minute, uh, then we should have provision for scaling. Remember, we have discussed about CNAME record in DNS. You can have many servers at the back end, farm of server, and all will be having one alias name, Microsoft.com or Google.com. Fine. So server is believed to be always on host, having permanent IP address, and then server farms for scaling. Clients are the entity which communicate with server. They may be intermittently connected. They may be on, they may be off. Whenever they want to connect to internet, they can connect. May have dynamic IP address also. You take your laptop to a airport, you'll get different IP address. Your laptop is in home right now, it's having a different IP address. Your laptop is in hostel, different IP address. Fine. But when you talk about the mn90.ac.in website, that is having a permanent IP address because mn90.ac.in is having a mapping with the has to have a mapping with IP address, and that has to be entered into DNS record. Fine. So this IP address of mn90.ac.in web server is kind of permanent. Fine. So because as and when you change this IP address, you have to do all those changes recursively in one DNS, in other DNS where this a particular address is cached, and so on and so forth. So when we say client server architecture, the general thing is that server are the system which are always on, and these servers are said to be in passive open mode. Passive open means they are passively active. It's a contradictory statement. Passively active means they are active, but until and unless somebody requests, they will not respond. And when we talk about client, they are active open. Active open. So these are the chaps, these are the entities which actually start the communication towards server. And server is sitting idle, silent, but is vigilant about what requests are coming. And as and when a request comes, server will respond. This is how this client and server architecture is envisaged. Fine. Peer-to-peer architecture. And firstly, we are seeing pure peer-to-peer architecture. It's like no always on server. There are some arbitrarily end hosts which connect to each other and can communicate directly. Fine. And because they may be mobile, they may change their IP addresses, they can be intermittently connected. Having said that, we want to have a communication paradigm. We want to have an application which follows this paradigm. That there is no clear cut server. How many of you have utilized uh, or used DC++? Yes. How many of you have used DC++ in hostel? Shares?
Sir, by the time I came to know about it, like in second year, no DC++ server was active at that time.
Okay.
So,
And how many of you have used BitTorrent?
yes, sir, torrent have used.
So what do you do in torrent? You search for prospective providers? Yes or no?
Yes, sir.
The first step, you have some torrent file, and then you search for some prospective provider, and then you have connection with those systems. So DC++ is also same like that. It's a BitTorrent kind of thing running within a LAN, fine, within a campus. So when we say peer-to-peer, it's like there is no always on server. There's nothing like DNS and these things happening. Fine. There are means to know that who can provide me my desired data, and then you can make direct connection, and it's a kind of client to client connection. And this paradigm, this way of thinking is not known as peer to peer, that clients can communicate directly. It is highly scalable, but it is very difficult to manage, because it is very difficult to provide some guarantee, because you are downloading a file from one machine and that machine suddenly moves away, or that machine suddenly switched out. So it is very difficult to manage. But still, this peer-to-peer architecture is very popular, and basically for file sharing application, for uh, the technical word is for non-mutant, non-mutable data items, like your movies, your MP3 files and all, which are once made, they are non-mutable. Not no changes are going to happen in that. So for those kind of file sharing applications, this peer-to-peer paradigm is very much popular. Fine. Where you are not required to give any guarantee regarding bandwidth, regarding delay, regarding jitter, regarding time of completion. You are not actually worried about those kind of guarantees. Then you are happy if your file is getting downloaded from any of the peer who is having that file in, say, 5 minutes, 10 minutes, 20 minutes, or 2 minutes. You are not actually worried about that. Fine. So in these kind of scenarios, these pure peer-to-peer architectures are very much helpful. What is currently getting utilized is hybrid of client server and peer-to-peer. Mostly popular for voice over IP peer-to-peer application. Skype uses this. Centralized server is there, Skype centralized server, to maintain your login credentials, details, and your presence. And once you know that whom you want to contact, once you know the IP address, current IP address of the remote party, then server is not in picture. Then direct client to client connection is there, not through server. There is a centralized server or a group of centralized server at different locations to maintain your login credentials, to maintain whether your friend is online or not. All those things, a central server does that thing. And afterwards, once you start communicating, this is peer-to-peer. Instant messaging, same like that. Chatting between two users is peer. Gtalk is peer-to-peer. There is a centralized service or centralized server which can give you the presence of client, detecting presence of client or location of client. All the user first of all will connect with central server when they come online, and then they tell their IP address to the central server. Now your friend, if you want to contact to you, will also contact to the central server, and that central server will give you the friend's IP address, and then once you get the IP address of your buddies, the rest communication is peer to peer. Fine. Any questions here at this point? Any questions at this point of time? Yes, Athar, any question?
No, sir.
Bhavya? Bhavya is not there kya? Madhav Agrawal, any question? Pranay, Priyanka, Rachit, Avasthi, any questions?
Not yet.
Okay. Okay. So let's come to the implementation aspects. When we say on internet communication is happening, actually there are processes which are communicating. And process, you know, that is a program running within a host. We have done this thing in our last semester, that within a same host, when two processes communicate, we can use inter-process communication tools like pipes and named pipes and message passing to have communication between two processes. And when you want to communicate between processes which are running on different hosts, then they will communicate in the same manner the way they communicate in inter-process communication within a system by exchanging the messages. And as I told you, the client process are the process which initiates the communication, actively open. They will actively open the connection. And server processes are processes that are sitting silently and waiting to be contacted. And they will respond, and they become active once somebody will send a request or somebody initiates a communication. And that's why I said server processes are passively open. They are open, but they are passive in the entire communication. Socket. Okay. Uh, Shares, electrical socket you have seen.
Yes, sir.
Fine. So if we go and see the electrical socket uh, like this, these are the sockets. Fine. Uh, I can connect a laptop here, laptop charger, mobile charger, your oven, washing machine. Fine. So analogous to this electrical socket, like once you are just connecting your application with the rest of the network using the socket. So you want to, if your laptop is a network application, laptop is connected to socket, and now you are not worried about that how that particular electricity is coming from, where it is coming from, which substation it is coming. You are not worried about that. So to get electrical network, to get for to get electricity, you have electrical socket. Similarly, to hook your server or client processes with the rest of the network, we have these sockets or endpoints or the doors. So if a process wants to send any message, process just shove this into the socket. If a process wants to receive any message, that process will pick the messages from the socket. Now, what is actually happening? Suppose I want to have a network application. Whenever you create a network app, that network app would be having two components. One is client and other is server. Or in peer-to-peer, one is host 1, other is host 2. Now, if they want to communicate, they both will create a endpoint at their end. And this endpoint or the connection interface is known as socket. Sockets are provided by languages like Python, Java, C++, C, and then they have support in your network operating system. So you are not worried about what is happening beyond this point, that how this message which you have shoved into this socket is getting transferred through the internet and reaching to your communication partner. You're not worried about that. That is going to be taken care by your operating system. You can use sockets provided by your operating system calls provided by your operating system, like what we are going to see in our lab. We are going to see Unix sockets or Linux sockets, and we'll be seeing some system calls to create to socket and to have communication. You can use socket interface provided by language libraries like Java and Python. The ultimate thing is same. Create a socket at both end. If you are sending message, just send to the socket. If you are receiving message, just receive from the socket. And rest other things are not your worry. And that's why this particular thing sometimes is known as API, application programmer interface. We always say it's a socket API. So you just need to know how to create a socket and how to use that socket in your network application code for sending data or for receiving the data. And rest is not your worry. That API is self-sufficient to contact your operating system, to do all those networking thing layer wise and transfer your packet to the other end. Fine. How to address the process? Every host is having a unique 32-bit IP address if we are talking about IP version 4. And as you know, to receive message or to send message, processes, these applications running on different host machine require identifier. Now the question we have already discussed, does IP address of a host on which process runs is sufficient for identifying the process? The answer is no. Because in that host, which is having one IP address, there might be many network applications running. The Facebook, the Google Talk, the Skype, the Microsoft Teams, many network applications might be running. So only IP address of machine to identify the process uniquely is not enough. And that's what is written here. Many processes can be running on same host. So what is needed? We already have seen this thing, the port numbers. Port number is a logical entity, fine, which can be concatenated with your IP address, fine, which can be associated with the IP address to uniquely identify the process. And as I told you previously in the lab classes, both and this port number identifier is transport layer identifier. So when we talked about those 6 identifiers, there was source port and destination port, and these were provided by the transport layer. And actually these port numbers with the IP address, these two things are given to the socket, are associated with your socket to uniquely identify the process which is attached with that socket. So in both transport layer services, the UDP and TCP, this source port, destination port fields are there in header, and these fields are of 16 bits. So roughly 65,000, more than 65,000 sockets can be supported per protocol, UDP or TCP, on a machine. There are certain port numbers which are IETF popular protocols, which are reserved, like HTTP server. If you are having a HTTP server application, that will always be running on port number 80. In our institute, you have seen that our proxy servers run on port number 3128. So whenever you configure proxy on your browser, you give the proxy's IP address and proxy's port number. And that proxy server application is running on this IP address. And that server application is listening for the incoming request on this port number 3128. Similarly, the HTTP server might be, suppose you want to send HTTP message to some institute.edu web server. So you need IP address of that server machine, and then the port number, because you know that it is a HTTP server, it should be running on port number 80. And both these are bind with, later on we'll see that bind is a system call, are bind with the socket you have created. So the major takeaway from this slide is that, or from previous two slide, is that to initiate the communication, you require a socket. You need to create a socket at both ends, and then you need to bind this socket with the IP address of the machine and a port number to uniquely identify the process or the processes which are communicating. Any questions here? Jam Mihir, any question?
No, sir.
Tanishq, any question?
No, sir.
Okay. Amit, Dr. Sangeeta, any questions?
No, sir.
No, sir.
Okay. So let's move ahead then.
Sir,
Yeah.
there is one doubt.
Yeah.
Sir, we are all using port number 3128 for proxy in our institute, right?
Mm-hmm.
So how does that work? Means we all are connecting to a single port, but we can parallelly work with it.
That's an interesting question. Actually, let me shift to my whiteboard. Athar, you asked this question, no?
Yes, sir.
Okay. Now, the question what Athar is asking, let me rephrase your question first, and then you say whether I have understood you clearly or not. Okay, Athar?
Yes, sir.
So, suppose there is a web server. Fine. And inside that web server, we are having a web server process, the web server machine. And this web server is running on port number 80. So here a socket is created. Here a socket is created. Fine. And it is running on port number 80. And then this particular socket of the web server on which it receives the requests, this particular socket is bound with port number 80 and the IP address of this web server machine. Now a client A request, client B requests, client C request, client D is requesting, and actually thousands of clients are requesting. And every client is using destination port 80 and destination IP, this web server IP. Now the question is how to handle all these requests. Have I understood you correctly, Athar?
Yes, sir. Yes, sir.
This is what you wanted to ask.
Yes, sir.
So the question is, there is one process. Now later on we'll see that these servers are of different types. The iterative, where the connection requests are getting handled in a for loop. Fine. That one request, then another request, then another request, then another request. There are concurrent server. And these concurrent servers can be multi-processed or multi-threaded. Means, as and when another request will come, this server will fork. Or this server will create another thread, depending upon what type of architecture it is. Am I clear now?
Yes, sir.
Athar?
Yes, sir.
Now, that's the duty of your operating system actually. Got my point? That if load is there and there are more number of clients and you want to support all the clients concurrently, then you have to have this forking of that server process or threading of that server process so that more number of requests can be handled. Is it okay now?
Sir, by getting this, I have another doubt then.
Okay, no
Means,
problem. Keep on asking.
means how will it identify that only my application has contacted it? Means we are having parallel applications, right? So how will it identify that it had to run one particular application
Okay.
out of those parallel ones?
Okay. Let me answer this. Suppose machine A, fine, and there is a web server. Okay. So machine A has given a request here, fine, and machine B has given a request here. Okay. Now the question is how this web server will able to answer to this or this. This is what you are asking?
Yes, sir. Means how will it identify that? Means we are having suppose constant communication between web server and us. So if I send a one particular request, how will it identify that it's me that is sending the request, and it has
It's
to run
you
that particular
because you
application?
are having your source port and source IP also with the request.
So means each time it has to run a particular application, it will check the source port and source IP of the
Obviously,
coming request.
when you send a packet, fine. What means each time you send a request, a packet will be generated, okay? And that packet would be having your TCP header or transport layer header or network header, data link header, fine.
Yes, sir.
And then this transport header and network layer header are having your source port and source IP, and using this source port and source IP, when the reply comes from server, this source port will be taken as destination port of reply and source IP will be taken as destination IP of reply. Got the point?
Yes, sir.
Okay. Any other doubt to anybody else? Okay. So now this point is clear that we require both port and IP address to identify a socket, and which actually means to identify the process which is connected to that socket. Now, when you have an application layer protocol, suppose you want to design your own application, or when you design an application, actually you are trying to design a application layer protocol. So you need to think about what are the types of messages which are going to be exchanged. For example, request message or response message. What would the message syntax? How many fields are going to be in message, and how those fields are delineated or separated? Message semantics. What is the meaning of these bits inside different fields? How to decipher this information? How to get meaning out of this? What is semantic? And then rules that when and how processes are going to send messages or respond to messages. So whenever you are developing an application, actually you are developing an application layer protocol. So you need to think about that, okay, what type of messages we are going to exchange? Request, respond, ping, probe, fine. What is the syntax of different messages? What is the meaning of different fields in messages? And when and how a process can send or receive messages. Fine. Now, while you are developing an application layer protocol, you need to think about what kind of services, what type of services you need from the layer below. And what is the layer below? Layer below is transport layer. Now, you need to think whether your application can tolerate some data loss, like audio, video, some of the frames, some of the bits are also, if they are not reaching, some of the data packets are not reaching, you can tolerate. But when you are transferring files or you are doing remote login, you require 100% reliable data transfer. And having said that, your layer below transport layer, the network layer, as we have already discussed, is unreliable. Best effort. Your network layer on internet or your IP protocol, internet protocol, is unreliable best effort. It will make best effort to transfer your data packet from source to destination, but it cannot give any guarantee. Packets may get lost, may get corrupted, and everything can happen. So what do you want from your transport layer, knowing that your underlying layer is unreliable? So you want your transport layer to actually hide or not hide the flaws of network layer and provide services to application layer. So if application layer says that I cannot tolerate any data loss, then transport layer will try to hide the problems of network layer and provide a 100% reliable service to application. Some applications say that they require low delay, like internet telephony, interactive games, to be effective. And some say like file download. That okay, this delay is not an issue, but reliability is an issue. Some applications say, no, maybe less reliable, some of the data can be lost, but delay should not be there. Similarly, throughput. Some application like multimedia require minimum amount of throughput to be effective. Okay, some 10 Mbps or 500 kbps throughput is needed for this particular application to be effective. Other application like file downloads and all, web browsing and all, make use whatever throughput they get. If throughput is less, your web page will be downloaded slowly. If throughput is more, your web page will be downloaded quickly. But for YouTube and other video on demand application, you require a minimum amount of throughput to be effective. And that is how judiciously these protocol designers have protocol designers working in IETF has designed these different protocols. Fine. That what kind of quality of service is needed. Accordingly, different transport services are required. Now, some example like file transfer, data loss, no loss, throughput can be elastic, time sensitive, no. Email, 100% reliable, throughput can be elastic, time sensitive, no. Web documents, same. No loss is tolerated, throughput can be elastic, time sensitive, no. Real-time audio video, loss tolerant. Throughput for audio 5 kbps to 1 mbps, for video 10 kbps to 5 mbps. Time sensitive, yes. Delay should be below some hundreds of milliseconds. This is real-time live audio video. Stored audio video, same as above, loss tolerant. But yeah, delay can be few when we talk about deferred live or something like that. Interactive games, instant messaging. So depending upon what kind of application you are designing, these kind of quality of service requirements are there. So what internet protocol stack provides you? It provides you two services. The TCP service, transmission control protocol, and UDP service, user datagram protocol. And both these services are at two ends. UDP is too much lenient and TCP is too much strict. What TCP provides? Before any data transfer can take place, client and server will actually negotiate many things. Remember in last lab, we have seen the SYN type of packets, synchronization packet. So before any data transfer can take place, both sockets, both end processes will say hello to each other, will negotiate so many things and something like that. It provides you reliable transport. If there are packet losses, the retransmission and everything will happen, and your application will get an illusion that there is a secure pipe or secure channel between these two entities and host. No data loss is there. It's a reliable channel between these two. Flow control. Suppose at one end you are running a workstation with 16 core and 32 thread. Fine. At another end, you are running a low-grade mobile phone. So this SAP workstation can create data very fast. But this low-grade mobile can receive data with its own pace. So flow control is like a receiver can tune the sender by dheere bhejo, so that sender would not be able to overwhelm the receiver. Another interesting thing what TCP service provides is the congestion control. It's a very interesting aspect. We'll be coming to this in our transport layer module, and we'll be actually spending at least 2 lectures on this. The TCP running at both ends can actually gives you provisions to control the congestion if it is happening in the network. In the network means the network in between these two communicating partners. If routers are getting congested, if switches are getting congested, if they are getting congested and packets are getting dropped, if routers are experiencing more load, their processing delay is more because more data is coming, so packet may be dropped and they are feeling congested, then TCP can also do this. TCP can throttle the sender according to the current network condition and can ease off the load of the network. What TCP does not provide: timing, minimum throughput guarantees, and security. What UDP is the other limit? Provides nothing. It's just a no frill extension of IP. Fine. It does not provide connection setup, reliability, flow control, congestion control, timing, throughput guarantee और security. कुछ नहीं provide करते. It's just an extension of IP, unreliable data transfer between sending and receiving process. It just provides you this multiplexing that, okay, there are many UDP applications, so we can have many sockets running on UDP with different port numbers. Nothing else is provided by UDP. UDP is just a no frills extension of your IP. Now there is a question, this is a price question, and if somebody will be able to answer it, first 3 answers I'll listen. If those first 3 answers are correct, I would be giving some credit on this. The question is, I want to have an application whose requirements are not as stringent as what TCP provides. Suppose I want um, reliability but no flow control and congestion control. My application needs reliability but no flow control or congestion control. Means, if you're getting my question, my application require services which cannot be satisfied by this or this. The UDP provides nothing and TCP provides you everything. If I choose TCP, I have to take flow control, congestion control, everything. But what I need actually, I want just connection orientation and reliable transport, but I don't want these two. If I choose UDP, UDP provides you nothing. So it will not provide you reliable transport also. If I choose TCP, it gives you flow control and congestion control unnecessarily, which you don't want. In that case, what should we do? 5 minutes. First 3 answer, I'll listen. You can raise your hand after 5 minutes. Don't Google it, think by yourself. Yes, anybody wants to answer this? सिद्धांत त्रिपाठी.
Hello.
क्वेश्चन समझ में आया?
Sir, actually, I went somewhere for 10 minutes earlier, so I was just asking the question from my friends.
Okay. श्रेय निगम. श्रेया निगम. Shreyas Tandon.
Yes, sir.
You didn't get the question, it seems.
No, sir, I got the question.
Mhm.
But sir, I'm not sure of the answer. I think we should use TCP, and if we are getting some extra things, we just need to take it. If we don't get what we need, then there's no sense of it, so we can't use UDP.
No. Anybody else? Athar?
Sir, don't we have an option for another kind of protocol? Means if TCP is not okay, UDP is not okay, then a third protocol.
No. Yeah. Priyanka Verma, Niharika. Anybody else? Mihir. Jatin?
Sir, can't we pick and choose the uh, things that we need in TCP? Like there should
No, it's not like
there
that.
can
It's a monolithic code. You cannot just pick and choose the things. Heramba? Yeah,
Sir,
uh,
will use TCP for uh, where we need it. Like we have to ensure that a data should be a connection should be established before data
that's what I
giving, and
said.
then you do.
I need connection orientation. I need connection establishment. I need reliability, but I don't need congestion control and flow control.
Sir, so like in YouTube also, videos are in UDP, and then other things can be from.
On YouTube, video is coming in UDP.
So if live
This is
streaming is there, so
no.
we don't require.
You are living in a different world. I'll tell you later on. Okay. There are so many interesting things which are going to happen in coming 1.5 months. Okay. And now, it's very sad that whole batch is not able to answer this. The answer is very simple. Anybody else wants to try? Answer is rather simple, actually. Uh, Answer is simple. If you want service in between, always take UDP. And whatever you need, code that thing into your application. And that's why UDP service is provided to you. If you want anything, if you want, you don't want whole of TCP, you want some of the aspects of TCP, those aspects have to be implemented in your application. Suppose you want reliable transport, you need to include sequence numbers and packet numbers in your application and use UDP at the lower layer. This makes sense, Athar?
Yes, sir. Means we are building on something basic and building
Obviously,
up to it.
because you cannot pick and choose, like Priyanka was saying, can we pick and choose some of the modules? It's not going to happen, fine. Because once you take TCP, everything will come. So take the bare minimum at the transport layer and whatever extra you need, implement at your application. Got the point? So this is a very popular question which is asked many times in interviews and all. Anyway, so if I take these internet applications and corresponding transport layer protocol, uh, email uses TCP. So SMTP, Simple Mail Transfer Protocol, which we are going to see in this module, TCP. Telnet remote login uses TCP. Web www uses HTTP protocol uses TCP. File transfer protocol FTP uses TCP. And Animesh was asking about YouTube. YouTube is started with UDP, fine, and started with RTP, fine. YouTube and other multimedia applications. But if you see clearly, YouTube runs on your web browser, and it uses HTTP, and HTTP uses TCP. So YouTube actually is using TCP, and it is an interesting thing. And if you want to know more about this, there is a thing known as DASH, Dynamic Adaptive Streaming over HTTP. This particular DASH protocol was developed by a consortium which includes Adobe, Microsoft, Google, and all big guns, because they wanted to provide streaming services, browser-based streaming services. Then they worked together to create this MPEG dash. Fine. How this dash works, we'll be seeing this. I'll be teaching you this dash later on. If you talk about internet telephony, so there is SIP, real-time protocol, and then other proprietary protocol is Skype and all, service initiation protocol SIP, and they typically use UDP. Fine. Now, if you talk about what we are using right now, we are using TCP. And this is what you can check using Wireshark. You run YouTube and run Wireshark, you'll be able to know it is using normal HTTP GET method to get your frames to show you the movie, and those frames are HTTP messages. Using GET messages of HTTP, those frames are coming, and actually underlying it is using TCP. That is what is the interesting aspect. And there are another interesting aspect of Dash which will be coming to it later on. Anyways, you got the point?
Yes, sir.
Okay. Fine. Web and HTTP, this is the most popular thing. So first, a review of a web page. Web page consists of objects. If you see a web page, there would be text, there would be GIF, there may be images, there would be some movie inside that, flash content. Fine. So web page may consist of objects. Objects can be HTML file, JPEG image, Java applet, audio file, whatever. So when you write a URL is of this type, uniform resource locator, that www some school.edu / this is the folder and this is the PIC-GIF. This would be the object which you want to be embedded in your web page. Each object is addressable by a URL. So when you open a page, actually different objects are coming from different URLs. So there would be an index.html file, base HTML file, and are you familiar with this term href? So if you
Yes,
see
sir.
the yes,
Yes, sir. We are familiar with href.
yeah, you use this href in HTML coding, no? So in href you actually give the path. In a web page, if you want to include any object, you'll be using this href thing. Okay, let me show you if I can. Suppose I open a web page, say IITD dot ac dot in. Suppose I open this web page. Fine. So you can see here there are many objects. Emblem is there, then some Flash content is there, the virtual tool is there, many links are there, and I don't know whether if I want to see view page source, so this HTML code would be available, and now here you can see this href thing. Fine. Are you able to see this href? Hyper reference. So these images and everything are actually there in the HTML file which you are getting at your machine. Then your browser running at your machine will parse this HTML file, will able to see these href things, and will try to download these PNG and all these images and put these images on that web page, and then this web page will look like this. Any questions here? Is it clear to everybody? Yes, Athar, is it okay?
Yes, sir.
Okay, so that's what I was telling you, that a web page can consist of many objects. Fine. Now, what is HTTP? Simple overview. It's a web application layer protocol. Uses client server model. Client is a browser that requests, receives, displays the web object. Server is your web server program which is running on a machine, remote machine, which sends the object in response to the request. So how the protocol works, there would be HTTP request and HTTP response. So browser makes HTTP request and server gives you another. So whether you are running Internet Explorer or you are running a Netscape Navigator, the server will give you web page, and more often than not, these web pages looks like same whether you are running Explorer or Netscape Navigator. Fine. So this is how this HTTP works. It uses TCP at the transport layer. Client initiates a TCP connection. Your browser makes a request. It will go to a socket. Fine. And socket and then below this, between your application, which is browser, and your transport layer or TCP, the socket will be there, and then this TCP will initiate a connection. Fine. The way TCP does, three-way handshake is there. So TCP initiates a connection with the TCP running at the server. TCP running at the server. Connection initiation will be there. Connection will be established. Fine. And where this TCP connection request will be sent to the server's IP address and port number 80, as I already told you. Server accepts the connection. Once this connection is made, then HTTP messages can be exchanged over this connection. When your work is done, your messages are exchanged between browser HTTP client and web server HTTP server. The TCP connection is closed. So for initiating the connection, a special purpose SYN messages are sent from client to server and server to client, both end. We'll see that in transport layer later on. And for closing the connection, a special purpose FIN messages are sent between TCP running at the both end. HTTP is stateless. Server maintains no information about the past client request. Fine. Suppose you have contacted a server today at 10 a.m. and then you have contacted the same server at 11 a.m. So what you have done here at 10 a.m., no state would be maintained with the server. HTTP is completely stateless protocol. Two types of HTTP connection. Initially, when we used to work, it was HTTP 1.0. Nowadays, HTTP 1.1 is running, and other versions are also there. So non-persistent TCP, for every object, a different TCP connection is established. Persistent HTTP, only a single TCP long-lived connection is established, and all the objects would be sent over this single TCP connection. So the difference is very clear that for non-persistent HTTP, every object required to have a TCP connection underlying for the transfer of the object. And persistent HTTP, multiple objects can be sent over a single TCP connection between client and server. Suppose let's see the non-persistent HTTP. Suppose a user enters a URL, some school.edu, some department home.index. And this particular web page contains text and href references to 10 JPEG images, suppose this web page. So first step, HTTP client initiates a TCP connection to HTTP server, the process at this edu on port 80. HTTP server at host this, waiting for TCP connection at port number 80, accepts the connection, notifies the client. Connection establishment is done. HTTP client sends HTTP request message containing the URL into TCP connection socket. Message indicates that client wants object some department home.index. That's what you want to open. HTTP server will receive the request, creates or forms a response message containing requested object and send message into this socket. So ये अपना message request message will send in its own socket. Server will send the response in its own socket at their own end, and rest is the responsibility of the network operating system to transfer these messages. And after sending home.index page, the base HTML page, the skeleton HTML page, fine. TCP server closes the TCP connection. Browser receives a response message containing HTML file. It tries to displace the HTML, parses the HTML file and finds that there are 10 hrefs there. Fine. Then step 1 to 5 are repeated for each of these 10 reference object. तो पहले connection पे first connection index.html, then that index.html is parsed, is interpreted. Then you found that there are 10 more reference objects. For every object you again create or establish 10 different TCP connection. As you can see, the response time will be more. And response time in internet we calculate in terms of round trip time, the time it takes for request to reach at another end and response to come back, this particular time. So when you send a request and you get the reply, this would be your round trip time. What is definition of RTT? Time for a small packet to travel from client to server and back. Response time 1 RTT to initiate the TCP connection. पहले एक RTT लगेगा TCP initiate करने में. A bit more than 1 RTT. We'll be seeing it in TCP connection establishment later on. 1 RTT for HTTP request and first response index.html. You can see this is the transmission time. 1 bit, 2 bit, 3 bit, 4 bit, and then this whole time would be transmission time. So some RTT, 1 RTT for this index.html, some more time, the time it takes to transfer the file. So the total would be 2 RTT plus the transmit time of index.html. और अभी केवल index.html आया है. Now, for every other packet, for every other object, you'll be having 1 RTT for TCP establishment plus 1 RTT and little bit of more time for transferring that object. So for every object, suppose there are 10 objects, so 10 times this much time and plus 1 time the index.html transmit time. So this would be the response time of non-persistent HTTP. What is persistent HTTP? First of all, the problems of non-persistent requires 2 RTTs per object. Operating system is having more overhead because for every object it has to maintain the TCP state and connection. And in our time, we used to have some software like Download Accelerator Plus and all, which can be plugged into our browser so that we can open parallel TCP connection which are working parallelly to fetch reference object in a fast manner. If we have multi-core architecture or multi-processor architecture, so that browser can open different threads to download different to have parallel TCP connection to download the different object a bit earlier. What is persistent HTTP? Server leaves connection open after sending response. In non-persistent, if you can see, after sending a response, server closes the TCP connection. But in persistent, the connection will be left open. Subsequent HTTP messages between same client and server sent over this open TCP connection. Client send request as soon as it encounter reference. वो उसने parse कर रहा है पेज, पहला href देखा, दूसरा request भेज दिया, फिर दूसरा href देखा, request भेज दिया. So on the same TCP connection, these requests are going from client to server. As little as 1 RTT for all the reference object. Because you are continuously sending request over the same TCP connection, as little as 1 RTT for all the reference object. So this is persistent HTTP. Now here I want to tell you one important aspect which may not be covered in your book, but in nowadays it is very much important. Please be very attentive. This is the important aspect. How many of you have heard this term, CDN. In the context of networking.
Sir, content distributed network.
Content delivery network or content distribution network.
Sir, it store static part of the website.
Yeah, it's not that. It's static or dynamic. Fine. Right. Anyway. Anybody else want to say something? Yeah, Shreyas, anything you want to say?
Sir.
Yash Goenka, you want to say something? Okay. So, as Hiramba suggests, it's a content delivery network or content distribution network. Nowadays, what is happening? Suppose I'm a website and my website is having many heavy contents, my images and all. So, and suppose this web server, say, suppose example, yahoo.com is running somewhere in Silicon Valley in America. And this yahoo.com is getting open from India. So for all the objects, whether it is, nowadays we don't use non-persistent, it's a persistent HTTP. So even if it's a persistent HTTP, all the objects will come from America to India on that TCP connection. And this has got its performance penalty. So what these websites, hugely accessed websites and having heavy content, they do, they take help of CDN service providers. Like Akamai is the most popular and mostly used CDN service provider. So what these CDN service provider has done, they have got their CDN servers all over the world. Right? Maybe in India, 4 or 5 CDN servers of Akamai, or maybe more than that. Now, when I make a request to yahoo.com, so obviously the DNS entry of yahoo.com will give the IP address of Yahoo server, which is somewhere in America. So my first index.html page will come from that America server on my browser. When my browser parses this page, because this Yahoo is using CDN facility, so in place of href, there would be something.akamai.net/this image. Another href, akamai.net something.image, means the images which are going to be on this web page are not coming from the original yahoo.com server. They are coming from different CDN servers of Akamai. Or instead of akamai.net, you can just write down the IP address of that CDN server also, which I have seen both of these things. So for running this href, again, you have to run DNS to get the IP address of this akamai.net CDN server, which can provide you this image. Or in place of akamai.net, if it is directly IP address written. So even if you are having persistent HTTP, where only one TCP connection is formed to transfer all the object over this TCP connection, if CDN is in picture, you have to make another TCP connections, because now the IP address is changing. Your image is coming from a different IP address, and yahoo.com server was on different IP address. So for these hrefs, you have to make different TCP connections. Is it clear, Athar?
Yes, sir.
Because TCP connections are going to be different. Fine, because your IP address, your destination is changing. Let me see, and let's see whether we can open that yahoo.com page and see what is happening. Yahoo.com. Fine. So I have opened yahoo.com. Fine. And if I want to see the href, let's see whether we can see or not. So you can see that href are coming from some different server. Right? yimg.com and something like that. They are not coming from the same server. So this is what is all about this CDN. More detail will come later. I just wanted to tell you about the CDN thing and the role of CDN. Fine. So different kinds of messages, like HTTP request message, two types of messages, request and response. This is how your HTTP request message look like. Request line will tell whether it's a get message or a post message. Then there are different header lines, which host you want to connect to. Get index.html, HTTP 1.1 is getting utilized. What is your browser, user agents, Firefox? What encoding you are going to accept? Language. What is the character set? All these things keep alive. This tells that your TCP connection would be persistent. Fine. This is, and then connection is keep alive. This is keep alive parameter. How long this TCP connection will remain open. Fine. So this is the HTTP request general format. Method, then space, then URL, then space, then version, then carriage return line feed. Carriage return line feed means enter and then line feed. Header field name, value, CRLF. Every header field name and value is followed by CRNLF, carriage return line feed. And then there would be entity body if you want to send some data also. Two methods. Get method, entity body is nothing because you are sending just the URL. When you are using post method, suppose you are filling a form, so then your input can be uploaded. Then your input can be uploaded in this entity body. Generally, nowadays we don't use post method. We use get method only, and whatever input is there, it is uploaded in the URL only. You might have seen when you use Google search and all, you might have seen this question mark, this and this, this and this. So in get method also you can post the input. Your input can be made part of the URL, and using get method, this URL you can include where your input can also go. But if input are more, if you are writing a blog or something like that, and then trying to post the blog, you can use the post method also. Method types in HTTP 1.0, there were 3 only: get, post, and head. Head is for the troubleshooting. Ask server to leave the requested object out of the response. Just not in positive that you got the request. It's just like a ping thing that you can ping your HTTP server is working fine or not. Now in HTTP 1.1, these two are there, but these two extra are there. Suppose I am a network admin, I am an administrator of that website. I want to um, uh, simply change my website or include a web page using HTTP interface. One way of doing the thing: sit on that machine and uh, include another web page or create a new link or do all those kind of things. One way of doing the thing is this. Another way is using HTTP only. You can use put method to put the things on a web page, or delete message to delete the files which are there in URL field. Fine. So in HTTP 1.1, you can get a control panel of your website. If you are a website admin, and use put and delete methods to change the look of your website. Response message. Response message, date will come, time will come, Apache server configuration and operating system will come. When this page was last modified, this will come. Point connection, keep alive, content type, whether it is text, HTML, or image, or whatever, content length, accept ranges, and then data. Data. Fine. Some status codes will come, and status phrase will also come. You might have seen this: moved permanently, 404 not found. Fine. These are two more common: move permanently and not found. 200 OK for OK, 401 for bad request, and 505 for the HTTP version you are trying to use is not supported by the server. Fine. So this is about HTTP protocol and their methods. I think we can stop here. Fine. And your CRs are there today or not? Vinayak?
Yes, sir.
और वो भी है क्या दूसरा, क्या नाम है उसका, भूल जाता हूँ. Another CR is not there? क्यों विनायक? उसको क्या दिक्कत है आज? कुछ थोड़ा सा हल्का सा चेंज. लेट मी स्टॉप द रिकॉर्डिंग फर्स्ट.